With a recap of the first attempt for this question, you can find the link below. Binary three-level order traversal 2. Now, this was the second problem in July challenge of Leetcode. The solution is logged, so what we're going to do to get access the discussions is search the question on Google along with Leetcode, and you would find a link to the question. So I've included this link below, and that's how you can access the discussions. I have opened a few discussion pages that would be useful. So we're gonna focus on Python. Looking at the topics here, it seems like both BFS and DFS can be used for the problem. Now, this question is the most voted. When I searched for Python, this is 128 votes and has around 20,000 views. So let's see. I think this solution does look beautiful. It does it with a lot of different ones, and all of them are quite short. So alright, so let's just check the BFS plus Q first, because that's the most similar to our attempt. Our attempt was a little bit longer though. The code's right here. It's a little long, but this is much shorter, as you can see. Alright, so what they do is they initialize Q as collections.dq root comma 0. Alright, and they initialize res as the final thing, so this would be the final answer, I'm guessing. While q node comma level equal to q dot pop left. Okay, so they keep adding on the right, popping from the left. If node, so if the node's not empty, probably. If length of rest is less than level plus 1. Okay, so length of res. Okay, so res was the final answer. So in the answer, if the if it's less than level plus 1, then res dot insert 0 comma a blank list. Okay, so if it has 5 elements, then we have 5 levels, and the current one, why less than level plus 1 though? So okay, because they're starting from 0. Yeah, so the thing is that their count is gonna start from 0, so root is gonna be at the 0th level, but the length of res will still be 1, so that's why it's level plus 1 here. And so basically what it does is, suppose we start with the root node. Now you add the root node as a list in the res. Now the length of res is 1. When you go to the next level, the level will be 1 and length of res is also 1, but you want it in a new place. So level plus 1, we'd compare the length of res with the level plus 1. So that's the idea. If we are at the first level, with level plus 1 is 2, if 2 is greater than length of res, which is 1, then it should add another list. So that makes sense. And what it does is res of minus level plus 1 dot append node dot val. Okay, so alright, why though? I think it could have just appended at the first place minus, yeah, I think it could have just appended on the 0th index, because okay, yeah, because it's a BFS. If it were a DFS, then things would have been a little different, but it goes minus level plus 1, so from the end, the for the root node level will be 0, so it would be minus 1, so it would be the last element, then minus 2, minus 3, and so on. Alright, so that makes sense. In that list, it appends the node.val, and then q dot append node dot left level plus 1, q dot append node dot right level plus 1. Okay. Alright, so basically it's the logically the same thing as our first attempt, just that the code's much cleaner, much shorter, and in a way that removes a lot of redundancies or extra lines, but it makes it a tad bit harder to understand. All right, so the next approach is our DFS plus stack and DFS recursively. We're going to go with DFS plus stack. It takes the root, stack has the root comma 0, res is empty, while stack, stack dot pop. So it's making tuples basically, just like in this approach as well, tuples of the node and the level. In our case, we were just adding it inside the node itself. All right, cool. So if a node, so if that means if it's none, then go on. Otherwise, go with the node. If length of res is less than level plus one, same as BFS, res dot insert 0 comma blank list. Okay, that's the same thing that they were doing. Res of minus level plus one dot append node or val. Oh, okay. So that's why they did this, because so that it works with both the BFS and DFS, and they don't have to write the code again. And stack dot append node dot right level plus one, stack dot node dot left level plus one. Okay, so it's pretty much the same thing. The complexity is also going to be same because BFS and DFS have the same complexity. And then they finally do it recursively, which is they call they initialize res, call DFS root 0 res, and they return res. And here in the recursion, what they do is self root level res if root, okay, so if the node's not none, then if the length is same as before, adding a new sublist and appending it. Yeah, pretty much the same thing. So it's just recursive, nothing changes. They just call the DFS function here instead of going over it. So that's that. If you have any doubts, please feel free to write in the comments, and I'll be more than happy to address it. You'll find all the links, all the relevant links in the description below. Thanks a lot. Bye.